Expressing a network as a list of nodes and edges is not very illuminating. We get a much clearer view of the graph when we draw it. But what's a good way to draw networks in general? There are two basic rules. Nodes connected by an edge should be drawn near each other, and nodes should not be so close that they overlap. We can implement the first rule by imagining the edges as springs that resist being stretched. These are not real springs, of course, so they can pull with any strength we like. A commonly used force law is this, where d is the distance between the nodes. We don't want the nodes to collapse into a black hole, so we add some repulsive forces too. We can think of the nodes as being like charged particles that don't like to get close to each other with this form of force law. When we combine these two formulas, notice that the force vanishes when d equals k. So the nodes want to be a distance k apart from each other. Any closer, they'll repel, any further, they'll attract. There are some more details. For example, we let the force change the velocity of the nodes rather than the acceleration as in a real physics simulation, and there's also a temperature parameter which slowly turns off the force over the course of a simulation. You can look at the paper for more details about it if you're interested, but for the rest of the video, we'll just look at some nice graph layouts.